SRB hydraulic power units have started. T-minus 21 seconds, and the solid rocket booster engine gimbal now underway. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
January 28, 1986, a leap for mankind became a tragic accident. 73 seconds after takeoff, the Space Shuttle Challenger exploded, killing everyone on board.
Challenger now heading down range. Engines beginning throttling down now at 94%. Normal throttles for most of the plane, 104%.
Challenger Space Shuttle launch was meant to show the safety of space travel to the American people. In order to demonstrate the safety of space travel, the decision was made to include a school teacher on the crew of 7.
Running normally, 3 good fuel bills, 3 good APUs.
The concerns of the engineers were overlooked. One of the reasons for this was that in the past, NASA had launched spacecrafts in temperatures below 50 degrees without issue, and due to the political importance of showing how safe space travel was.
More delays than NASA cares to count. This morning it looked as though they were not going to be able to get off.
1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles.
Looks like a couple of the solid rocket boosters blew away from the side of the shuttle in an explosion.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Due to the failure of the O-rings, flames were able to escape during takeoff. When the flame reached the fuel tank, the shuttle exploded. O-rings are round rubber material that are used to keep gases and liquids from escaping. In space shuttles, they are used to keep flames from reaching other parts of the shuttle. What's really shocking about this tragedy is that people tried to stop the takeoff all the way up to the fatal day the shuttle combusted.
We were working on the O-rings over a period of time and saw that it was having a few malfunctions. Due to the weather, we continued to try and fix the issues, but we got the same results. We brought it up with the people in charge of takeoff and let them know that the O-rings would not be able to last for the weather conditions, but our request to postpone the takeoff was denied. We continued to proceed and see if postponing the takeoff until warmer weather, but we were denied. Instead, the decision was made to launch in the cold weather because they'd done it in the past without failure. If you look on the straw, you can see this small ring. This is an O-ring, and this is the type of O-ring that it doesn't keep gases in, but it selectively keeps liquids in. And so if you look at the cup, you can fill it with water, and you have the lid. And so you take the O-ring and stick it into this lid and put it on the cup. And the O-ring can keep water in when you're drinking from it, and the ring comes up to meet the hole. Or it can fall back in to let some air in and some water out. So this is selective. So while you're using the cup, nothing's going to get in or out. But while you're letting it sit, air can get in so that the water inside doesn't get stale. See, without the O-ring, when you turn it upside down, the water just falls out. This would be the case if you're looking at something on the rocket, the fuel could just come out. Bring in. The O-ring falls into place and water does not get out of the rocket. Okay, the patent for the O-ring was filed in 1937 by Niels Christensen, and it used synthetic rubber instead of natural rubber. And synthetic rubber is natural rubber with sulfur and other chemicals added in. The O-ring, it's cheap, it's affordable, it's easy to use, and it's easy to install. And for that reason, it's found in almost every country in the world, and in the majority of devices. So it's found in simple things like cups and straws, it's found in cameras, it's found in pistons. It's found in most machines that have parts that move. It's very important in devices like the Space Shuttle because it's so cheap to use, so easy to use, and so strong They can use it and be sure it's going to work. And if it breaks, it's not a complicated part that's going to take millions of dollars to build a new one and to replace it with. They just get the 10, 15, or a few $100s depending on what it's made out of. But the easy to find, easy to replace piece. The O-ring is one of the fundamental inventions of the modern era. It is a simple piece, a fundamental of complex machines. It has stood the test of time, and it will continue to do so.